You are designing APIs wrong because you are not following my 3 steps protocol advice. Just kidding. But seriously now, making a good API for your library is something very important, because bad API design will also lead to bad software. And if your API is used by many people, you'll have a visible negative impact on the world. API design is hard and most people do at most an average job at it. But you can do better. So let me give you the tips that I have accumulated over the years while designing my own APIs. For this, I will use a library made by me called SafeSave. The code is in C++, but the tips apply to other languages as well. So the key topics that we are going to cover are flexible design, easy to use design, and very importantly, hard to mess up design, plus some bonuses at the end. You will quickly see, however, that these 3 criteria are tightly related, so any design choice that I will show will probably improve the API in all of the 3 areas. It is needless to say that an API needs first of all to have a purpose. This API saves data for your game using some backups and other techniques, ensuring the player doesn't lose his progress if the PC suddenly closes while saving. Check out this video for more details. Some people, however, like to over-engineer stuff, abstracting simple things into APIs without having a need for that. As a rule of thumb, if you are working at a project and you are thinking of abstracting your stuff, maybe wait until you actually reuse that thing multiple times before you start making the abstraction. This leads us to probably the most important tip of this video, and that is to test your use case instead of assuming. So my API has multiple ways of doing the same thing, but while I was using it with my engine, I noticed a use case that I didn't think of implementing. So make sure you test your API, and whenever you think to yourself, damn, I wish I could do this in this API, you have found something to improve. Okay, let's look at real examples now. Something very important is to not force the user into using your API in a fixed way. This can include, for example, memory allocations. For C and C++ API especially, it is good to allow the user to allocate his own memory if needed. So the first way you can load a file using my API is to get its size, then create a buffer however you want, and finally read that buffer. Now of course, it would be nice to not have to type all of this every time, so I also have the option where the library allocates the memory for you. I chose to read the memory into a vector, because if I were to give back the data, then people maybe would have probably forgotten to deallocate it. Plus the vector also has a size. So having multiple ways to do the same thing is good for versatility, and notice that these functions are named the same. This makes it easy for the user to see that they do the exact same thing, but they are just different versions. Okay, now my functions return error codes. Some people might want to do something with that error code, like printing it, and that can be easily done like this. Most people will want to just check for any error, but not do anything with it. This can also easily be done like this. Now we get into a problem. The library also has warnings that you might want to get or not, and if you don't want to get them, you kinda have to start messing around with the error code to see if it is a warning or an error. So to not break this simplicity, the functions takes an optional parameter that tells if it should report warnings or not. If this is false, it will only report errors. I also have a similar thing for checking if the file size matches with the size that you have provided. Maybe you want to check for that or maybe you don't. This struct allows the user to save the data into a key pair binary format. Notice that instead of having a method to write the data into a file, I have a method that returns the data. This is more versatile because you can write it however you want. Or for simplicity, just reuse the write entire file function from the library that is made to work directly like this. The same thing goes for reading data. And of course, I also have a function that takes directly this struct to save the data for you. Okay, now what about easy to use design? Well, you already saw that with this function. You should provide a very easy to use function for the user to be able to easily integrate your library. He can switch to another version of that function that is more flexible later. The most important tip here is to try to minimize extra steps as much as possible. This library is first of all a header plus source only library, meaning that all you have to do is to add these 2 files to your project to use it. You can also use CMake if you want. Next, to use the library, you don't have to call any init function or set up any error reporting callback. You can just start using it. If you choose to add an error reporting callback, make it optional. And by that, I mean provide a default one that is used if the user doesn't specify anything. So think of the easiest way to use your library. If the thing can be achieved with just a function call, like it is the case in my library, adding classes and virtual classes with templates will just make the API harder to use for no reason. The standard template library from C++ is like this because their API has to work with any use case possible, but that's not the case for the APIs that you are designing. So if you will use your mess API only with floats, there's no need to add templates to add the possibility to use doubles. Finally, let's look at making the API hard to mess up. I think this was a quote by Mike Acton, and it is a very powerful tip. Many functions in Windows API are easy to mess up because they require you to pass the parameters in a very specific way. Try to minimize that as much as possible. Well, this is easier said than done, so let's look at some tips. This other API of mine called GelUI allows you to easily make a UI in a very descriptive way. You need, however, to be careful how you call begin and end, or how you pass unique IDs. So the library reports very explicit error messages, to tell you exactly where you messed up. You can also do this if the API requests you to call an init function. So try to add as many asserts and error checkings as you can. Also add the option to remove those in a production build. Now, the best way of stopping the user to mess up is to use the compiler checks. If you want a pointer that can't be null, use a reference instead of a pointer, making it impossible for the user to pass a null pointer there. If you want the pointer to be an optional parameter, however, maybe write that in the name, so it is clearer that it can be null. That's why I also request a vector here, so I can do the memory allocation for the user. You can also use const to tell the user that the data is read-only, or enums to make sure the user can't pass a wrong ID. And finally, we get to some bonus tips. It is worth mentioning that I managed to build safe API functions on top of one another. This will of course make it easier to fix bugs and to implement multiple function variations without duplicating code. Also, for your C++ APIs, it is good to allow the user to provide a custom memory allocator. And finally, if your API needs to hold on to some data, try to hold it into a struct rather than globally. Now this of course depends on the use case. My 2D rendering library holds some data both globally, and you also have to create a renderer. This allows the user to create multiple renderers, and they'll share some global things that didn't make sense to initialize once for each instance, like a driver function pointer. So these are my tips, but feel free to let me know how wrong I was in the comments section, because no one can seem to agree on programming design tips. If you found this video useful, share it to a friend and subscribe to not miss out on more content like this. And don't forget that I have a video on how my safe library works. See you there!